So let me turn it over to Madeleine to kind of walk through some background so we all have an understanding of what it is, and then we'll talk about kind of marketplace issues soon.
Great, thank you. A lot of unfamiliar faces, so quick poll on the scale of 1 to 3, where 3 is extremely familiar and 1 is not so familiar with ATSC 3 or NextGen TV. How many people would put themselves in category of 3, pretty familiar? Yeah, Peter, very good, yes. How many 2s? And 1s? Wow, and some people aren't fessing up, so okay, that works. All right, good. Well, so this presentation is going to give you a little bit of a background. I'm not going to get into the deep technology. It's really going to be an overview. If you get asked to do an introduction of ATSC 3.0 and they give you 10 minutes, it's going to be a little bit across the surface, but I think the idea is to give you a quick introduction of what ATSC 3.0 is, and then talk a little bit about the deployment, what's going on in 2020 and what's going on across the world in my colleague's country in Korea as well. So a little bit about ATSC 3.0. ATSC 3.0 is a new broadcast technology, and the idea behind ATSC 3.0 is that broadcasters need to modernize. Very, very important to modernize. The current standard is 20 years old. How old is your latest Netflix app? 3 days? 3 months? So modernization is extremely important, and the broadcasters and ATSC got together and said, okay, we need a new standard in order to modernize for now and also for the future. And what does this thing need to do for us? Well, certainly it needs to have more capacity. And Luke Fay was chair of the physical layer group when that work was being done, and we have achieved that goal with 30% more capacity right out of the gate. Better reception. How about mobility? Wouldn't that be nice? So that was also on the table. Again, thank you to Luke's group for getting that done as well. Early technology experiments showed Amtrak train. The miracle about this was the Amtrak train was actually going 124 miles per hour. That aside, the mobile picture was beautiful. And this was very early on. This was like 2015 or 16, I think it was, that particular experiment was done. So better reception. Also, hybrid OTA OTT. This is the first standard for broadcast that is based on IP, and that makes it very easy to marry the over-the-top and the over-the-air systems. And enhanced consumer experience. So why we're all here today at CES is about NextGen TV, and I'll get into what that nuance that Brian alluded to, what's the difference between ATSC 3.0 and NextGen TV. But for the consumer, better pictures, better audio, interactivity, advanced emergency information, all kinds of things, better accessibility. And also the broadcasters say, hey, you know, I'm going to do this, I'm going to put a lot of capital into it. Yes, I want to keep all my customers happy and I want to keep up with all my competitors, but what else? So new business models for broadcasters, including advanced advertising, the possibility for pay-per-view and subscription, which comes along with the security services, also some service reporting and data casting. And then coming back to this one for just a minute, so NextGen TV. NextGen TV is the consumer-facing brand name of this system, and it specifically addresses the television parts of ATSC 3.0. But on the slide here, you see the very last thing on there is called data casting, and I think broadcasters can envision using the system to deliver data to anything, for any reason. Data to cars, software updates, Internet of Things, who knows? So the way we think about it is NextGen TV is the consumer-facing television part of what the standard does, and it is powered by ATSC 3.0, what broadcasters look at and think to themselves, the sky is the limit. So again, what I said earlier is the better connectivity and the IP backbone is extremely important. One of the transport protocols within ATSC is called route dash, and it is basically how to send dash over a broadcast signal. As many of you know, dash is divided up into segments and periods, and so when you have a period, you can make a splice, for example, between over-the-air and over-the-top content at the receiver. It's also possible to do with MMTP, which is the other transport standard. So having that internet protocol backbone is very important, particularly as we get into a 5G world and we look at other global standards, which are all IP-based, and how do we play in those worlds. So, video. Near and dear to our hearts. Right now the standard goes to 2160p or 4K. That does not preclude 8K. At the time, right now, the standard says this is how you do 4K. It doesn't say you may not do 4K, but it doesn't necessarily tell you how to do it. ATSC does have a group looking at future technologies, which has been kicking tires about 8K. My colleague formerly from DVB has also done a study mission on 8K. So there's a lot of discussion about what 8K can mean for broadcasters. For now, 4K. Spatial scalability, kind of more of the details. High frame rate, very important for sports and nature programming. High dynamic range, potentially as important, if not more important than 4K. And then, of course, wide color gamut, which goes hand in hand with high dynamic range. Pictures are stunning. And I look at all three colleagues thinking to myself, pictures are stunning. Yes. Audio. So it's been interesting. Our broadcasting counterpoints are thinking to themselves, well, what of this huge swath of things that we can do should we do? And so what did they do? They asked the consumers. Good idea, right? And one of the things that tested extremely high was advanced audio features. One of which is, so there's two audio systems. There's the Dolby AC4 and the MPEG-H standard. Dolby AC4 is what's going to be used in North America. MPEG-H is being used in South Korea. There's dialogue enhancement or voice boost. A lot of my friends turn on closed captions just because it's easier to follow the dialogue. So the voice boost allows you to bring the dialogue up relative to the music and effects. And that was one of the surprises of the consumer testing. People said, I want that. And these are people that are younger than me and they can still hear. I'm like, wow, okay. Also, be able to have different selectable audio tracks. So maybe you have commentary, home team, away team. And immersive sound, which is quite amazing whether you're looking at, whether you have speakers or a sound bar or even headphones. The immersive sound is amazing. Dynamic range control, making sure that the sound is uniform across everything. And then also very much improved coding efficiency. So now we can send more in the same amount of capacity. Interactivity, so describing the conceptual application model. Most important thing here, I'll skip through some of this detail. The most important thing here is that it's based on standard web technologies. So it works in a standard browser. Yes, there are some things we want to do on TVs that we don't do on computers, and those are in separate WebSocket APIs, but the point is you can get an off-the-shelf browser and it can do ATSC 3.0 interactivity, which is great for broadcasters because you guys already have, the broadcasters have digital departments where they design web apps all day long. They can translate their skills directly into television interactivity with this system. Mobility. So here's a couple of pictures which are kind of fun. I'll show these again a little bit later, but this is the Pyeongchang Olympics, and this is NAB from 2018, where we had the autonomous vehicle both in the central lobby as well as driving around the convention center, at least as long as the wind didn't knock over its little barriers and stuff. That was kind of funny. Anyway, security, one of the most important things. Secure path to the transmitter. Signed signaling in tables and apps. Oh man, signed signaling tables are boring. But from the TV point of view, this is what allows the TV to know for sure that this app or this content was sent by a bona fide broadcaster and not by somebody else. So that we don't have wardrobe malfunctions and other strange things coming on our TV due to bad actors. Content encryption is also extremely important, especially for the high quality content. If we're going to be delivering 4K over an internet protocol, we want it to be safe. So content encryption is included using, again, looking to marry the internet and the broadcast system. We use the common encryption systems that are used by the internet providers like Netflix and Amazon and whatnot. And it protects the content, and it also allows broadcasters to think about other business models. Hey, maybe my basic service is going to be free. Maybe it's going to be free if you register. Maybe it's going to be free and the premium service is going to be for subscription. And you could envision business models merging between set manufacturers and broadcasters for these types of things. Who knows? Advanced emergency information. My esteemed colleague John Lawson from the AWARN Alliance is right over here. If anybody has any in-depth questions about advanced emergency information, he's your man. So advanced emergency information does not replace today's EAS systems. All those regulations stay in place and we still have to do all of those things. This is optional for broadcasters and optional for receiver makers. It delivers rich information about emergency, video, HTML5 pages, audio, images, so the evacuation map that you need to see, which could in fact be delivered to your car. It enables viewers to dismiss a message and later recall it, and receivers in standby mode can monitor for emergency messages and wake up if need be. And it could be done within the native receiver, or it could be done in one of the broadcaster applications that I mentioned before in the interactive section. And then geo-targeting is possible, audience targeting is possible. So for example, we need to tell the first responders what the suspect looks like, but we don't want it to get out to the general public. First responders communication network might not be up if they're using, for example, cellular, and the cellular network is busy. So ways to get information to first responders. And there's much to come. So Korean deployment, I'm going to spend a little bit of time on Korea because a lot of questions come up and say, so when does this happen? What's happening in 2020? What's happening? When is this going to be done? When are you going to have critical mass? All these questions like this. I mean, you have to think about what happened with the HD transition. And the HD transition in this country was mandatory. We went from analog to digital, and we said we're going to go HD. It still took a while. We remember we had some programs available in HD and some in SD, and over time more and more in HD. And then, hey, along came the diginets, meaning the second channels. Took a lot of time to kind of roll in all these features. So we look at Korea and understand what's happening there because they were first. They deployed commercially ATSC 3.0 in 2017. Their goal was to have it on the air by the Olympics for sure. No excuses, do it. And they did. But you can see how their cities rolled out. So here's the deployment rollout, starting with Seoul, and then moving on to the big cities, in particular Pyeongchang, where the Olympics took place. And then as you go through time into 2020 and 2021, they're starting to get full national coverage. It's going to be very similar in this country. We're going to start with the bigger cities. We're going to move forward. Right now, broadcasters are anticipating 60 markets in 2020. And that's their goal right now. I have to say thank you to LG for these slides. Our friend JP. So priority number 1A was 4K UHD. They did it in standard dynamic range, so they haven't put in HDR yet or wide color gamut. Priority number 1B was the interactive portal, which they call TVVA. And the interactive portal is a way of marrying the OTA and OTT. What it does is it allows you to seamlessly move between linear content over the air and VOD content over the top. So a little bit more about their roadmap. As I mentioned, phase 1, 4K, most important, interactive portal, most important. And then as they look to the future, they're looking at mobile HD. They're looking at advanced emergency messaging, which there was an announcement this year. And they're also kicking the tires about 5G and ATSC 3.0 and how does convergence work and such like. And they're proposing a facility on Jeju Island to really study that in depth. And here are the partners that are thinking about that. And by 2027, no more ATSC 1 in Korea. 10-year transition plan, get it done. And furthermore, not is there no more ATSC 1.0 in Korea after 2027, there's no more HD. All programs are 4K by 2027. All right, so that was what they chose to do. Here in the US, we started with some test markets. We had 8 of them up. I think most of the 8 of them are still up. I think a couple of them have become victims of the repack. And we have 40 additional markets that are planned. These are the top 40 markets. And we have 21 additional markets on top of those top 40 that we're planning. And so the hope is that roughly 70% of the country will be able to see ATSC 3.0 services in 2020. That's the anticipated goal. So what about our feature roadmap? That's our deployment roadmap. And we assume that it's going to grow from there. But the features are another one. And this has been always the fun part, talking to our colleagues both in the television world as well as in the cable world. So, okay, you've got 40,000 features you can do and internet and blah, 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 blah. What are you really going to do? Because we got to build this thing. We got to test this thing. So talking about the feature roadmap. Now, caveat here, this is not engraved in stone. This is not a great consensus amongst ATSC membership or CTA membership or NAB membership or anything like that. This is a sort of a guess about what we're probably going to see. So thinking about service features in 2020, I expect that we're going to see the audio stuff, which tested extremely well. So consistent loudness and the voice boost. And I expect we're going to see 4K and HDR videos. So there's going to be some 4K HDR and there's going to be some full HD, 1080p, not 1080i, with HDR and wide color gamut. And we're going to see some immersive audio, and that's probably going to be on some select programming, kind of the way HD rolled out, a little bit at a time. I could envision the television roadmap coming up later. The next service features, maybe in 2021, beyond, more consistent loudness and voice boost on more programs and more cables, and looking toward cable, more content in 4K and HDR, and also looking at some of the other enhancements that could come along, such as the advanced emergency information, multiple audio tracks, different kind of interactivity. So again, Maddie's crystal ball, take it with a grain of salt. But the idea is that this is not all going to be done in 2020. This is going to be a rollout over time. And also, ATSC is continuing to study mobile, data casting, 5G convergence, international recognition, all kinds of stuff going on. And I should stop because I'm probably well over my 10 minutes, but I wanted to give you guys that background, and then I think we'll carry on the conversation.